Shown here is the leg assembly for an egg chair, which consists of a support post for the seat itself, 4 branching leg structure, and a single foot that's going on the end of one of the legs. Accurately building this is deceptively difficult, and I've looked for some ways to simplify the process. I'll roll back the feature tree and show you what I'm talking about. Rolling back to just a single leg, the actual chair leg is crowned on the top all the way from the tip of the leg to the center where the post is located. And then there's a sharp edge radius running along the perimeter of the upper edge. In order to do this properly, you actually have to build this entire surface as a fill surface and then add a fillet at the end. Making that fill surface requires making a lot of temporary surfaces and is very tedious. I've come up with a way to do all this that looks fairly convincing and saves about 10 steps. The creation of the cross-shaped leg structure itself only takes about 17 steps, and the rest of the steps are adding the foot that go on the end of the legs and the post. I'm now going to roll this all the way back to the beginning of the feature tree so we can see what our layout sketches look like. On the top view, we see that each leg is tapered as it goes from the center of the structure out to the ends. And I've also drawn in this the top view of the little foot that goes on to the leg, the location of a screw hole that holds the foot onto the leg, for the screw that holds it on rather. And I've represented just one adjacent leg. In this case, I've fully drawn out the right hand leg and just one line of the forward leg so that I could draw in the radius that blends the two together. I've also drawn this outer circle, which represents a flat area which is just a little bit bigger than the diameter of the post, and then the diameter of the post itself. This line here is a mirror image of this 45-degree construction line. As usual with my videos, I've just guessed on a lot of these dimensions, so don't use these dimensions, use whatever you measured on your own chair. I'll zoom in on this a little closer so you can see this all at once, and then move on. The front layout illustrates the leg showing how it tapers downward from the center out to the ends, the side view, or rather the front view of one of the feet, and the post itself, which goes partially down into the crossing leg structure. I've also included a plane that's going to be right at the bottom of the post, because what we're going to be doing is having a hole in the crossing structure and then inserting the post into it. So starting with our first actual solid feature, all I'm doing is copying this line here from the top view, the 45-degree line, and then the outer perimeter of one leg, and trimming it all together to get this final result. So you're going to have a lot of crossing lines that you have to trim to get a clean single perimeter. And then I'm extruding it so that it is intentionally a bit higher than the front view of the leg, because I want to trim this or cut all this material off later, but I want to have some excess, which you'll see the reasons for later on. Going to the front view again and turning on my sketches. To get this downward slope, I'm doing a revolved cut, which is copying this downward line from the front view layout and doing a revolution around the center of the post. And this gives me a surface which has a slight curve to it if this is not actually a flat surface. Now, the actual legs have a lot of draft angle on them, and that has an effect on the styling of the product. So we want to add somewhere between 3 and 5 degrees of draft to these surfaces, 1, 2, 3, and we want to leave these surfaces undrafted. So what that means is that we could not do this extrusion by adding draft while the extrusion was being made. So when I add the draft, I'm going to use the option of using the neutral plane My top plane is the neutral plane, and I'm drafting these three faces, 1, 2, and 3. And if I turn on my tangent lines and then roll back for a moment, we can easily see how these surfaces were vertical and now they are drafted, making this upper surface narrower than before. As I mentioned before, the true nature of this leg is that this top surface is crowned, and that crown is sort of following this perimeter around to this 45-degree angle, and it has to go perfectly normal to this surface so that when we mirror this leg on the 45 degrees, the crown on this surface will match up with the crown of the adjoining surface. That involves doing a lot of temporary surfaces and making a fill surface to make that all come out right. That's a fairly time-consuming process, so we're going to cheat a little bit and get something that's going to look pretty good. What we're going to do is simply add a fillet to that edge, but we're not going to add a normal fillet. We're going to add a variable radius fillet, and we're not going to use a circular fillet, but we're going to use an asymmetric fillet. So I'll just show that process manually. I'll get out of here and roll back so we don't see the fillet. So choosing the fillet feature, the option I want to go with is the variable fillet, and I want to choose these three edges. And the option I want to use on the variable radius is this asymmetric option, which gives me the ability to make the fillet be greater in one dimension than it is in the other. Right now it's defaulting to 0.12 inches downward and 0.12 inches inward, but we're going to be changing that in order to get this surface to look like it's crowned with a little bit of a fillet where it blends in with the main sidewall of the leg. Zooming in here first, we'll just work on each piece of the fillet at one time. And I think in this area, what I want to do is make the fillet come down about 0.05 to 0.07 inches. And going inward about 0.12, at least on this model, looks about right. When we're all done, I'll point out what I've done and why I did it. So this radius here is going down 0.12, and I want to change this to about 0.05. We'll see how that looks. Okay, that's not too bad. We'll do the same over here. So now you can see what it looks like when you have an asymmetric fillet. It looks very elliptical in shape. In fact, I think I'll bring it down a little bit more, maybe 0.07. And do the same on this one. And the key here is not to go so far inward that we totally obliterate this upper surface of the leg. If we go over too far, what's going to happen is when we mirror the leg to the other side, we're going to get a sharp edge or ridge. So we want to make sure that there's a little bit of a flat left here. And actually this isn't a true flat, as I pointed out before. Zooming out here, we'll go into this area, and we've got more width to work with, and we got a lot more height to work with, so we can make the fillet in this area bigger. I think going down about 0.12 is pretty good in this area, but we want to go inward more now, so we can go inward as much as, say, 0.2. You see the width of the flat area here is about the same as you saw at the end of the leg. And then we finally get to this area here, and I think we can go down a little bit more here because the leg is taller in this area. So let's go down 0.15 as an experiment, and we can go in a lot farther. We'll go in about 0.25. So that looks pretty good. So you notice that the shape is this elliptical shape. We have another option we can use. That's under the profile setting. We can go with elliptical, or we can go with curvature continuous. When it's curvature continuous, this shape gets more bulgy because this has to flatten out before it joins this surface here and this upper surface here. That might be a little more bulgy than you want, so maybe if we just go back to elliptical, that might be a little bit nicer, especially with regards to how it looks at the end here. I'll just change the two so you can see the difference. So elliptical, curvature continuous. I think maybe I like elliptical a little better. But that does mean that there will be an abrupt change between the curvature of this fillet and the curvature of the sidewall. So that's the only downside there. We also see that when I use that, I'm getting a dark line here. I have my tangent lines hidden right now, so this means that from here to here is not perfectly tangent. So let's go back to our curvature continuous and see what happens. So maybe I'm just going to have to live with that option. So what I've done here, by using this type of a fillet and bringing it as close to the center of the leg as possible, is I sort of faked the appearance of a surface that is crowned with a radius running along the edge, because it's very flat curvature here and much more highly curved here, just like a separate fillet would have been. So I think that's a good workaround, which saves us about 10 steps, as I mentioned before. Again, don't trust my dimensions. Play around with that asymmetrical fillet until you get it looking right. We'll zoom out here. I mentioned that there's supposed to be a flat area on the top. I purposely waited to put that in last because I wanted to make it easier to get this asymmetric fillet into place. So the flat cut at the top is just copying this straight line from the front view and doing a simple extruded cut. That gives us a surface here which looks somewhat circular. This area diverges from being circular because it's intersecting with this asymmetric fillet that was put in place. I'm then going to put a blending fillet on that edge here. I tried putting in a cord width fillet, but for some reason it didn't work. So I just put in a conventional fillet. In this case about 0.3 inches, something that just blends these together nicely. That's the basic leg right there. You can see how few steps this actually took. I'm going to put a little fillet on the bottom edge of the leg. We don't want that to be dead sharp. And now we're ready to mirror it on the front plane so that we have one complete leg. And of course we have this 45-degree wedge on the end of it, which is going to let us pattern this around and fit together with the other three legs. Before we do that though, we're going to put a little tapped hole down in the bottom for a screw that's going to hold the foot on. I'm going to demonstrate how to do that. I'm just assuming that we're going to put in about an M4 screw here. So what we do is use the hole wizard, which we haven't done very much. I'm going to click on the surface first where I want the hole to go, then select hole wizard. And the type of hole I want to use is a straight tap. A tapped hole is a hole that has threads in it. I want to make sure that the kind of hole I'm using, if I'm going to use a metric screw, says ANSI metric. I can also select ANSI inch if I want, depends on what type of screw you plan on using. I want to use a bottom tapped hole or a tapped hole. Either of those will work fine. And then under hole specifications, I'm going to select M4. I want it to be a blind hole. I don't want it to go all the way in. And Solidworks will default to a depth for the hole and the depth for the threads that is typically used for an M4 screw. So you can just go ahead and leave those unchanged. And I want to make sure near side countersink is unchecked. And then I go to the Positions tab and I hover over my surface and click the area or right where the center of my sketched circle is in my top layout. So that will bring the circle right in alignment with the layout point, which is the center of that circle. Click the check mark, and now we've got a hole that has a little point on the end, and it has a little dotted line going around it to indicate that that would be a threaded hole. So it only takes a few seconds to do this. It took a lot more time to explain it. Now that we have the hole, we have an entire leg that we are ready to pattern. I'll pattern this using a circular pattern going around this edge, giving me 4 legs. Unfortunately, there's no merge command when you do a circular pattern, so I just have to use the combine command to combine these into a single body. I'm going to hide the edges again. Then I'm going to add this post hole in place. I'm going to make that hole sketch on the post hole bottom plane and just copy the circle from the top layout into extruded cut going upward. That's going to be the hole that the post goes into, and I just put a little fillet along the edge of that hole. And then I wanted to put a hole in the bottom of this so that we could have a screw come up through the bottom that would screw the legs to the post. In this case, I'm assuming a much bigger screw, and in this location it won't be a threaded hole. This would be the hole that the screw would simply pass through but not thread into, and I'm assuming just a big flathead screw like an M8 screw. So in this case I want to have a screw with a countersink on it, so I can use a flathead. And then what I want to do is be choosing in my hole type metric again, and then I'm going to select countersink. I'm going to select M8. In this case I want the hole to go all the way through, and just like before I'm going to position it so that its location is right on the center of this sketched hole in the top view. So there are the legs with all the necessary holes, and all we have to do is move on to the post, which is very simple, and the leg, and the foot, which is very simple. Moving on to the post, this is just a circular extrusion starting on the post bottom sketch, post hole bottom plane rather, extruded upward to whatever is the appropriate height. I'm not sure what is correct for this model. And we want to put some sort of a hole in the bottom here, a threaded hole that will match up with this countersunk hole. This time I selected, once again, a straight tap, M8, bottoming tapped hole, and it defaulted to these 2 dimensions for the hole depth and the thread depth, and then I once again placed it so that's at the center of the sketched hole. So if I isolate that for a moment, our post is nothing more than a circle with a threaded hole in the center. So the last piece is the foot. The foot is made by copying the sketch elements from the layout sketch and extruding upward and downward to this vertex here in the front layout and this vertex down here in the front layout. Then once again on the top plane, I'm going to do a new sketch, copy the appropriate lines from the layout so that I can have this slot that the leg is going to drop into, do appropriate trimming, and then just do an upward cut through all, but make sure it only goes through the foot and not through the leg. So now I'm left with a foot that the leg is neatly dropped into. I add a bunch of fillets to finish it off. And in the bottom here, I'm going to later on have a screw go in. And as I mentioned before, we're going to have an M4 screw. Or if you're doing this with English screws, maybe that would be like an 832 screw or something like that. And here I'm selecting my countersink hole. The screw type I'm using is going to be a flathead. The size is an M4, and we want it to go through all this part. We need to make sure on the feature scope that only the foot has been selected. We don't need to make the other feet because later on we're just going to save this foot as a separate part. We're going to assemble it in an assembly file, and then to get the feet in the other positions, you will be able to pattern that one part along with any screws or other hardware that we put in.